Okay, so here in this example, we have a gas mixture and it's 85% mole percent nitrogen gas and 15% hexane. And we know the volumetric flow rate, the pressure, and the temperature of the mixture. And first, we want to figure out what the molar flow rate of the gas is in kilomoles per hour. So we're just going to use the ideal gas law for this. And we can rearrange to solve for the molar flow rate. And that will be PV over RT. So we have a pressure of 2 atm, our volumetric flow rate of 100 cubic meters per hour. Our R is going to be 0.08206, and that is meters cubed atm over kilomole Kelvin. And then our temperature is given in Celsius. We need this in Kelvin, so we're just going to add 273 to it to get 373 Kelvin. And I can multiply that out and divide to get 6.53 kilomoles per hour. So now for part B, we want to know, is the gas saturated? If not, what temperature in Celsius would have to be cooled at constant pressure in order to begin condensing hexane? So here we need to figure out what the vapor pressure of hexane is and what we're going to use to get that is Antoine's equation. So Antoine's equation is going to look like this, where we have log 10 of the vapor pressure is equal to A minus B over T plus C. And in this form, our units are millimeters of mercury for our pressure, and we are going to be working in Celsius here with its temperature. So if I end up plugging in the values for A, B, and C, which are found in the appendix for hexane, and the temperature which we were given of 100 Celsius, that looks like 6.88555 for A, minus 1175.817 for B, over a temperature of 100 Celsius, plus 224.867 for C. And this right side is going to be equal to 3.26617. So that means that our vapor pressure is going to be 1845 millimeters of mercury. And then we are going to use, we're going to use Raoult's law to figure out the partial pressure of hexane. So now for Raoult's, the partial pressure of hexane is going to be equal to the mole fraction of hexane times the total pressure. And that is equal to, so we have 0.15 as our mole fraction, And then our total pressure is 2 atm. And let's convert this to millimeters of mercury so we're able to compare it. So we have 760 millimeters of mercury per atm. So that ends up giving us 228 millimeters of mercury. So this partial pressure of hexane is less than 1845, which is our vapor pressure of hexane. So because the vapor pressure is greater than the partial pressure, this is not saturated. And so, since this isn't saturated, we need to calculate what temperature it would have to be cooled to a constant pressure in order to begin condensing the hexane. So what we're going to do is use the Antoine's equation and rearrange that to solve for temperature. And we are going to set Antoine's equation equal to this 228 value, to what the partial pressure currently is. So we want to figure out what temperature our vapor pressure equals our partial pressure at. So plug in 228 here, and our constants stay the same. So 6.88555 minus 175.817 over temperature plus Celsius. And if we rearrange to solve for the temperature here, we end up getting that the temperature is going to be equal to, not 34.8 degrees Celsius.